If we now invite you all to ask questions, if you can ask questions to any member of the panel or to all the members.
Hello. Yes. My name is Ling Fei Li from UMaine, basically. So I'm local. I just have a quick question for Joe. So I saw you did a pretty amazing life cycle assessment work on that. So, but I also noticed when you do the cradle to gate analysis for FRP and for steel rebar, you're basically using different database to make the comparison. I'm wondering, is there a specific reason of using different database, or because basically my concern is like from different database, you can get different global warming potential for the same material. So that's my question. Thank you.
So that CLF database contains data for a lot of different building materials. I think I had steel, aluminum, masonry, concrete. FRP is not in there. Someday I hope it is in there, but it's not in there. So I deferred to ACMA's LCI to get the data. And it looks at the different stages. That part is consistent. It does look at the different stages. And so it's yes, it's from different databases, but it is apples to apples. It is that product stage. Someday I hope that FRP is in that database and that people are building with it and using the values for FRP that are in it.
Keith Berube. Yeah.
Yes, hello. It's for Joe. Nice presentation. Question: you had your presentation indicated for cradle to gate, the savings was from 8 to 72%, but then when you did from cradle to grave, it was like 26%. That would imply from gate to grave, steel is better. I mean, do you know, is that just a proper comparison? Am I interpreting that incorrectly?
So if you looked at the typical value for the FRP rebar, it was very consistent with, I calculated 25% for the typical one. He calculated 26% for the whole thing. And it's pretty interesting. If you go through Thomas's data, there are quite a few values close to that 25, 26%. There are some that are lower, some that are higher. And so it kind of averages out. I think that was a coincidence, but if you go back to the typical value, it is consistent.
Okay, thank you.
Mm-hmm. Joe, I will follow up on Keith's question. In the example you presented by the group at the University of Miami, I think the Halls River Bridge, correct? Mm-hmm. The LCA. When you look at the analysis from a cradle to grave, I mean, considering all the life of the facility, how do you bring a longevity, and how do you factor the fact that concrete with FRP reinforcement may last more than concrete with steel reinforcement, and therefore it's not just steel versus FRP, but the savings in the concrete that now has greater longevity.
Right, and Thomas would probably do a better job of this than me, but when it comes to the Halls River Bridge analysis, they made the assumption that a steel bridge would last 75 years and that the FRP bridge would last 100 years. And so that replacement part is factored into that extra 25 years. And then the other thing they did, it's not exactly addressing your question, but for the maintenance part, Thomas did calculations that showed you reached a critical corrosion level, a critical chloride level after 12 years. So the maintenance schedule is based on doing maintenance on the steel bridge every 12 years. So when you look at the cost, it actually there's a jump every 12 years. And for FRP, it stays flat because you don't have to worry about corrosion resistance. It's a very, very detailed analysis.
Good. Thank you.
I wish we had more of them. If I had another need for the industry, is we need to have more life cycle analyses and life cycle cost analyses besides the Halls River Bridge. And I think places like the University of Maine could do that.
Thank you.
Good afternoon. Sebastian, PhD student here at the University of Maine. Since we are here, I want to talk about education. Hundreds of courses that certificate on composites materials all around the world. Most graduate programs in engineering include also composite material course, but it's very rare to find an undergrad program with such a course, including the curriculum, especially in civil engineering programs. What are your thoughts about it? Do you think it's time to start teaching composite materials at undergrad level? And for the guys in the industry, have the professionals that you met meeting the expectations you have about their knowledge in composites?
Well, I'll speak for my 25 years as a faculty member and 9 years as a chair. It's hard to change the curriculum, right? So many things we have to do. Having said that, there actually is room for it, and it does exist in some places. At UMaine right now, mechanical engineering offers an undergrad MEE 450, which could be taken by any civil engineer at our program for a tech elective credit, for example. And some undergrads take that class or Roberto's composite class before they go into grad school or before they graduate. But there absolutely is room for it in there. I think Roberto should probably speak to the challenges of teaching it at the undergrad level. You know, what you might run into when you're teaching it to civil engineering undergrads in particular.
Good point, Bill. Yeah, the challenges that we bring together and understanding of materials, the way they behave, strength of materials. That's a key topic for understanding composites and structural analysis. And it's really a great challenge. I mean, what Sebastian poses here, and Bill was correct. I mean, when we look at the curriculum, we have a number of limitations. Perhaps there are creative ways to address this, maybe through projects, maybe through short courses, certificates. I mean, the ability of students to get exposed to design codes. I guess we need to get creative, and I would like also to learn from our employers of our students. I mean, from consultant companies, from DOTs. I mean, what are the needs they see? I mean, how can we help educating students and again, accounting for all the constraints we have currently in the number of credit hours that an undergraduate program should have. I mean, we cannot go forever in teaching, but I mean, what are the key aspects that we can present and how? I mean, for example, again, going back to this concept of design projects that involve composites. Is this a way to go? Question for everyone.
So it doesn't deal with undergraduate curricula, but what we've really been trying to do, and when I say we, it's a collective ACMA, IACME, University of Maine, with conferences like this. We have been trying to educate the civil engineering and the construction community as much as we possibly can. In 2021 and in 2023, ACMA has had a very successful construction infrastructure tech day webinar series. IACME has made presentations to ASCE chapters. And here today, we're talking to an audience which includes New England DOT representatives. Yesterday, I gave a webinar to the Southeastern states, the Southeastern DOTs for an organization like SASHTO. And so we're really trying to make efforts to educate people, but it's after the fact. It would be even better if they did get a dose of it as undergrads.
And I think to add a little bit there, in the early years, much of the knowledge about how to work and design with composites was really at a higher level. It was in the graduate level. I mean, for myself, I mean, I was schooled in concrete and steel, not aluminum, not even wood. And I learned composites the hard way, from scratch in the field, making the mistakes and stuff like that. And after 40 years, I'm still not an expert because I don't do it on an everyday basis. So education, I have found in talking with the academic community in doing all of the standards development, developing those standards is the tool by which you can then teach from. So that's why even having the ACI 440 code published last year, there's the tool. You can teach to that because in concrete design, you're teaching the 318.
Yeah.
So you can utilize that as your basis.
Yeah.
it took 20 years to get to that point. But now that you have that tool, start exploiting that.
No, that's a good point, John. I mean, any section, as you mentioned in the new ACI 440 code, mirrors a section in ACI 318. And if there is no new material, it basically refers to ACI 318. That's my understanding, John. So there's some important concepts, like we'll talk about failure intention in the girders. And that is something that designers need to understand really well, how failure intention happens in composites. We don't have the ductility we see in steel. My understanding is, and I'm going to make a general comment, is the new ACI 440 code accepts either failure intention or compression in the concrete, compression of the concrete, or tension failure in the internal reinforcement, FRP rebar. There are some important concepts there that probably need to be clarified, and then give the opportunity to students to either use one code or the other. Again, they're exactly the same organization, the same sections, the same numbering, so they can basically go from one to the other in a simple way. Perhaps a capstone project, it can be an opportunity for students to do this exercise and tap into the opportunities for composites.
Do we have time for another one?
Time for another questions?
Roberto.
Yep. Oh,
It's-
I
it's
didn't see
hiding
you,
from
sorry.
you. Yeah, hi, Reed Miller again. John, question for you, for starters. When you look at the standards that you've developed, are there other advantages for using FRP within concrete design? For instance, can you have less concrete cover due to the lower corrosion resistance? I'm out of my depth right now, so I'm relying on the concrete experts in the room, but I'm just wondering, are there other sort of material savings and things that you get from using this, that off the top of your head?
Okay, so first clarification, it's not my standard, but remember I told you it was a village. There's a lot of other people smarter than me that really help make that. Theoretically, the design would allow that specifically in concrete cover, you can use 1.5 inch concrete cover when utilizing FRP. The reality is that with many practicing engineers, they're probably not going to change that. And I think it's going to come back down to experience and what can be done. Part of it is a site issue. If it's in a building, it probably wouldn't make, a difference. If it's a bridge deck, it may make a difference because of elevation. Okay, where that 2 inches is really there for elevation and not necessarily for corrosion resistance. So you're right, ideally from a sustainability standpoint, we have another tool that because of the design code, you can be more efficient in design. This goes back to the other question back there about, students in undergrad getting exposed to the design elements of composites. And I think it's going to be that progression that we're going to start thinking differently.
Great. Thanks for the clarification. Right, because the cement within the concrete is going to be a big driver of the embodied carbon.
Sure.
Another question for all of y'all, if we have some time, is we're talking about Maine, we're talking about New England. I'm thinking also about the global south, right? The population of Nigeria is set to double by 2050. India just overtook China in terms of population. There's going to be a lot of infrastructure needs and maybe reduced capacity for maintenance, so desirability for longer durable products. Is US leading the way, or do we see this sort of percolating across the globe? Or Europe, maybe, I don't know where they're at.
I've seen activity in Europe with bridges, a lot of pedestrian bridges, some vehicle bridges in Europe. They have I don't know whether you consider wind infrastructure, but they have a very strong wind industry in Europe. I'm not seeing that much in China. I know that there's a considerable interest of composites in Saudi Arabia. I think they're using FRP rebar more and more in their construction projects. So there are definitely global opportunities, and where I also see activity is in Europe.
Thank you.
I think where it comes back down to is where you're seeing, and it was brought up earlier this morning, the champions. So one would make the assumption that you would hope that every state that considers innovation a core value, and it goes back to, again, it was brought up, the culture, that they would be looking at all different solutions to help solve problems. So in the South, there's not too many champions that are leading initiatives, but if you want to consider a very good representative would be Florida DOT. And they have 3 or 4 champions within that state, that one of which is in a leadership position in AASHTO committees. And another one is a leadership position within the field that has changed the whole culture, but in partnership with University of Miami and other universities in Florida where they've exploited that. Can't say that's happening in Texas. Yes, they have elements for utilizing FRP in Texas, but our biggest champion just retired 5 months ago. And their replacements are not as knowledgeable as he was. So we're almost starting from scratch even, in Texas. So you almost have to go down to state by state as to who's been involved and who's been exposed. And, quite frankly, a lot of the people that we were working with some 20, 25 years ago, they're just about retired or just retired. So we're starting that cycle all over again, because internally there weren't a lot of education even within the DOT. So we, in some respects, I hate to say it, we're starting all over, but I think in a good way.
I'll just add, in addition to Maine DOT and Florida DOT, I've seen North Carolina DOT doing more and more with rebar. The state of Ohio is putting FRP rebar into a lot of their bridges. They're concerned about the corrosion with the de-icing chemicals in the winter. So very different than North Carolina or Florida. I've also seen activity in Oregon and Washington with rebar, with wraps, with the arches. So it's pockets, but it's a minority of states. What we hope is that word spreads among the DOTs, that when they have their AASHTO meetings or they have these regional meetings like this SASHTO meeting yesterday, that people tell their story, and then hopefully it will become a best practice.
Thank you.
Really, one comment you asked also about the international implications and how this technology can get to other countries. When John gave us the very comprehensive overview on codes and standards, I think, John, you mentioned ASTM D7957 for FRP rebar. That is also an ISO standard. That means that's internationally accepted. So it's all over the world. Those are the things we need. I mean, standards that are not just North America or the US, but are international. That's a really good, I would say, jumping board to move this technology forward in other places. We probably have, yes, go ahead. This may be our last question. I'm looking at Amanda.
Okay. My name is Muchur Shen.
Go ahead.
Associate Professor of Civil Engineering at Western New England University. So when we talking about the education, I was thinking about the composite structure competitions like steel bridge competitions or concrete canoe. So I know the ACI organized the FIP beam composite competitions. You guys involved in, or do you guys planning to work with the ASC to promote students' innovation, creativities, and then their education at the universities, where you guys can start with the University of Maine and then nearby, and then the FIP technologies can be disseminated through the nearby, where even Miami schools together, and then we can move forward. I just wondering where we are at.
So the concrete beam competition in ACI started in 1998, and it was to demonstrate what I would consider a very young FRP rebar industry in exposing students to the design of utilizing the 441R document in designing those concrete beams. It's taken a lot of maturity with an ACI so that they fundamentally own it. It used to be a Committee 440 initiative, and now ACI owns it. Our composites manufacturers provide the rebar. What's interesting about the competition every 2 years is that it has grown to the point that we've maxed out how many teams from schools that can participate. So we have an 8.5, 9-hour day of constant testing, in the hotel of beam after beam after beam with some incredible designs. And believe me, students absolutely read every word in the rules, and they figure out how to break every rule in the thing. But it's fun from an industry perspective to see this. So I think that was more maturity. Concrete and FRP is, almost synonymous. FRP makes concrete last longer and be better. So they like us. We don't like steel. So just keep that one clear. Integrating that into ASCE, and I was a part of concrete canoe, competitions and stuff like that. Integrating that into ASCE, I think is going to be a lot more difficult. Could that be, a program? I think it just needs to figure out how to develop it and sustain it. But I think within ACI, there's much more collaboration going on, but it's a fundamental, very good tool. And I would say the majority of the students globally, there's international schools as well as a lot of schools domestically that participate. It is absolutely shocking what they've done. And that has actually, impressed others to do designs differently. Again, because they learned how to break the rules.
Well, if we are on time, I would like to thank our 3 panelists for a great conversation. I personally learned a lot from the 3 of them.